This is Alex Zaharis and Nikos Tsagarikas. I had to practice like 10 times. Speaking about speaking about point of sale vulnerabilities, specifically in places that the TSA will not like them to go home afterwards, okay? So be nice to them because they're probably stuck here for the rest of their bloody lives after this talk. Gentlemen.
Hello. Thank you. Thank you for the introduction and the opportunity. As the introduction said, we're going to present a case study of an attack of a point of sales machine that is placed in an airport. Okay, let's say in an airport in general. Okay, this is a real bug founded in a real airport, but we're not going to disclose the names and stuff like that. Here you can see the contents of our presentation. Okay, and now I give the speech to Mr. Zaharis.
So, as you see here, we have lots of stuff that we're going to discuss about, especially about point of sales attacks. But before we talk about point of sales attacks, let's discuss about why to choose to target travelers. So, travelers are really vulnerable people. They are running around trying to catch a flight, and usually they don't think about where they access, what kind of wireless access they use or what machines they use, especially if they trust the place in which they use the machines in, let's say an airport, that it's supposed to be a place very trustworthy. So usually you have an average traveler running around, holding many devices and trying to jungle around, trying to catch his flight, and he carries his mobile phone, he carries his laptop, he carries his tablet, tries to find a connection, check his emails, maybe his corporate email. I know most of you probably think, okay, that's not an average security savvy guy, but a security savvy guy would usually trust a machine inside an airport. So we're talking about these guys too. So let's get a little better close-up look to the point of sales attack in transportation. It's a little bit different than usual what we usually know about point of sales attacks, like in commerce or the example of Target, where we target credit card details or web credentials. In our case, we're trying to profile the traveler, so we are looking about the names, the picture of the traveler, maybe his flight number, his destination, his seat, who is he communicating, and in the worst case, we're trying to get his passport or his ID. So we're talking about this stuff and not credit cards, which is usually what happens in points of sales attacks. So let's go through the ways usually a point of sales attack is introduced. There are three ways this thing can happen, this attack. We're talking about the first one in our case, but I'll go through all three of them. So the first is when a system is unpatched and is full of vulnerabilities that someone might find out and exploit the whole system, root the system, and then get the information he needs out of the system. The second way is that maybe an employee of a company, which is not aware of how things work about security, clicks an email, a link, or whatever, introduces a malware, a Trojan, inside the company's network, and it reaches to the point of sale system, so that's where you get the information from. Or the third way is that the employee himself is the bad guy, the inside man, that he introduces the malware in purpose in order to harm. So, first of all, who is going to benefit from this? Okay, well, there are three, but maybe more, but I'm quoting three there. Cyber criminals, usually for identity theft, in case of passports and stuff. Private investigators who just want to spy on you, or maybe the government, if they want to spy on you. And stay off radar, of course. And what do you get out of a point of sales attack? Well, as I told you before, we're trying to profile the traveler. And of course, without the consent of the airport, we don't get airport data to do so. We do it on our own. So what we can achieve is like at the end of getting information is that we can find out the destination and send queries like who is traveling from Greece to Germany the last month, who traveled, or which company is used by most travelers, or what class were these travelers traveling, or in that specific flight and date, who was traveling in that flight, or the combination of all the above. So here's the case study now. We're talking about a real airport back home in Greece, and this really happened. So the airport has, as most airports have, different systems that can be exploited the way we're describing here in order to steal information. So we have the check-in kiosks, which are probably you've all used before, where you automatically check in and get your ticket and go to travel. There are some systems that in our case we have exploited that you can purchase Wi-Fi time and have some other information. They're like info kiosks, let's say, that usually you can find in many airports. There are also you can find internet access points and luggage locator kiosk. All of them hold information that could be found useful by us as attackers in order to exploit and profile the traveler. Let's get some more information about the airport, some statistics to help us understand about how big is the attack vector that we're dealing with and how much people are affected. So these are real statistics from the specific airport. We're talking about around an average of 12 million travelers per year, so of whom 30%, as you can see, these are statistics from 2012 and 13, I think. 30% are business passengers, which usually are more interesting to attack or learn more about them. And let's say that's a hypothesis here. The first two numbers are real, but the last one is a hypothesis. Let's say 100% of them is using a point-of-sale system. We're talking about 36,000 people that can be attacked per year. It seems small, but it isn't that small. So hello, guys.
No, keep going.
Okay, I'll continue. So we chose to attack that specific machine because it seemed better than the rest. It seemed to have less security. It's supposed to, you can buy free extra Wi-Fi time from that. It accepts coins and bills in order to do so and gives you change back. You can check your flight details by scanning your ticket, your e-ticket, and you can also make VoIP calls. It has a webcam in it. And there were 6 machines in there.
Excuse me for a second.
Yes.
May I take the podium?
Yes, you
Just
can.
for a quick second.
Yes.
So, we have a first-time speaker, and for those of you who are not familiar, for the first-time speakers, we have a little bit of a welcome tradition here, and unfortunately we don't have any vodka. But
Who's the next time?
yeah, next time.
You guys are from Greece?
Yes.
Oh,
Verbon is fine.
We got the wrong information.
yep.
Cheers, guys.
Cheers. Yeah.
Yeah, let's see you read that shit down.
Here we go. You're nervous, no problem. We can take care of that.
A little bit of support here. Are you good?
I'm better now.
Would you like some help?
No, I'm fine.
Okay, good.
Thank you, guys. So I'll get this slide from the beginning because I'm drunk now. So purchase Wi-Fi time kiosks. You can buy Wi-Fi time. They accept coins and bills, and they give you change back. You can check your flights through scanning your barcode on your ticket, and you can make VoIP calls. They have a web camera on them. And there are 6 perfectly placed around the airport. So what a better thing to attack. So let's go a little bit more on them. There is a screen of the Wi-Fi purchase thing. This is for the VoIP calls. And this is the simplest attack you can do on them. You can press Alt-Tab and escape the front end. Also, there was something worse. Yes, the Alt-Tab thing didn't work from left Alt-Tab, but it worked from right Alt-Tab. They have locked one key. So, but this is not the worst thing. They also had the USB port open. Okay, so, you can understand what's going on here.
The USB port was clearly visible when you went in upstairs from the arrivals to departures. So when we went upstairs by the automated stairs, then you can see clearly the USB port.
You were doing the elevation thing and you were like, oh, a USB is open there.
Just like that.
So, okay, after going a little bit more about the system, we saw that we escaped the front end. We saw that it was a Windows 7, it had no antivirus on it, it had a connection because of the VoIP calls, and of course, it was getting worse and worse because if you would escape that thing, there were processes running on the background that they were actually giving you full control of the system. I mean, of the pay machine, the cash machine, everything. So they were running on the background. Really bad architecture there. So you could actually pay yourself some money, which we did, without, of course, using the machine. We just clicked how much money we want, and we said pay. And, you know, slot machines you've seen are worst. They're harder to get money. This was really easy. So, okay, some more pictures here. This is the communication with the process behind. The front end talking to the back end. Some commands, they don't make sense, but this makes sense. It's in Greek, but I will explain. This is how much money there are in there. It's around €500 per machine. And the good thing is that you can choose what type of money you want to get out of them through that console, where you can see down there is you just tick how much money you want. There is the pay button in the middle to get the money out of the system. So things were really bad. So Nick, do you want to talk about how we talk to the guys?
So why this happened? This happened because we travel a lot. We're using the airport to go around the world working in security industry. So when this bug was found, then we decided to inform the airport because it's not only the risk of losing money of the airport, it's also what else an attacker can do while have access on this type of kiosks. Okay, so we decided to call the airport. When we called the airport, they didn't believe us. They say, no, there is no way you did that. And then we called again. And it was 1 week time before they sent people to check it. Okay? After 1 week, they sent people to check the bug, and they called us back, and they told us, oh, you are lying, this is not possible to happen, because we checked it and it's not happening. And then we insisted, and we said, no, it's happening. And then they said us, come here to show it to us. And then we went there to show to them the bug. So after a while, they decided to fix the Alt-Tab issue. And then we decided to see if we can do further stuff regarding the point-of-sale systems in the airports and everywhere else, but most in the airports. We did more testing. After they fixed the Alt-Tab, there's still a possibility to have access from the Skype interface that locates your flight. They do a fork from Skype, an Internet Explorer, from where you can see your flight status and where your flight arrives. Then you can get access to go into Gmail and then you can get access to whatever URL you want. And from there, you can download whatever malware you want. Also, the Internet Explorer they have, it's an old version, so it's probably exploitable. We didn't try any stuff of this because it's highly illegal. Okay? Yes. No. So, just a moment. So we searched all the interface and we found these extra bugs. And the other vector we decided to test was the barcode fuzzing. So you have a lot of point-of-sales machines that have this infrared scanner, and from there they parse the infrared barcodes, the barcodes with infrared, and they send information back to the machines. Okay, so we decided to build an application that will generate random of these, or not so random, barcodes or QR codes to fuzz the applications. Okay. Here you can see the interface testing that I was talking about. You can see that there is a map showing the flight. If you point there, then it opens up a Gmail account Gmail to send, to log in and use Google Maps for further information. Okay. Here is the interface that it could be exposed again after the alt-tab fix. Okay, so you can have the pay option again for yourself.
They didn't fix anything.
Yeah, they didn't change that. Furthermore, this stuff, it was a really bad application. The service that you see before, this black screen, this one, if you closed this command execution window, the whole service went down. So they executed like something like a script and it started CMD cell, and then it ran the application, something like that. Whenever you scanned the code there, the code was displayed in this console. Okay, so that's one of the means you could take the passenger information from the QR code. And here we go. From here you could see the maps and you could go to the Gmail account information. Here you can pay yourself. And then we went back to the lab. So we found that it was very interesting that this kiosk had webcams on it. So if you own this part of the network, you can possibly monitor all the cameras of these machines, so you can take video of all the passengers passing by. And these machines were placed in 14 places inside the airport. So you can have a very good view of the passengers going around. Then we must have, the malware must have RAM scrapping capabilities, so can take all the necessary information from the RAM of the machine. And the fuzz tool that will be able to fuzz the infrared interface and cause more errors to this machine or any other machine like that. Okay. So here is the camera module. We're having issues because we cannot see the image here, so we are watching there. Okay. And here. So the functionality of the kiosk was the following. Whenever you went there to buy wireless time, you had also the capability of watching the flight information. So you scanned your boarding pass. The kiosk was decoding the QR code of your boarding pass. Then confirmed back with a web service the flight, if it's in time, or your information, if it's valid. That means that this kiosk has also access to a service that can confirm the passengers. Okay? And then it returned back the flight information if everything was valid. Or else there was a possibility for the application to crash. Also, there was a possibility to do network calls through Skype to whoever you wanted. From what we saw, it was possible to access wherever you wanted on the internet from that kiosk. So I will return later, because now Alex will continue, with the possible risks that are posing through this kiosk.
So let's talk more about the BCP code. Your tickets have what we say a barcoded boarding pass. It's actually a barcode that was introduced by the International Air Transport Association in 2005, and more than 200 airliners use. And some of them have the mobile version, 36 of them. What we show is that in paper, the most common is the PDF 417. And for the digital type, it's just the code or data matrix and QR code. Because we couldn't exploit all of them, we decided to do one from paper and one for digital, so the bolded ones are what we chose to talk about and prove our things in real life through a tool that we've developed. So a few technical information about the PDF 417. So except of the standard, all this stuff, what's interesting is that linear barcode, it's used in transportation and in identification cards and in inventory management. And what a ticket looks like inside is like this. This QR code that a PDF 417 code that I scanned. It's from a real ticket that belongs to me, and it holds all this information inside it. You can see the raw data under the QR code, under the barcode, and I have broken down the information of each field. So you can see my name there, you can see my flight, my booking, where I'm sitting, and from where I booked the ticket, and which airliner I'm using, my passenger seat, everything is there. So you know anything about my flight. Also, you can see if I'm a business class or what type of first class or what type of class I'm flying. Also, again, for the Ask the Code, here we're talking about the digital version of the same thing. It's usually present in mobile phones and handheld applications, handheld devices, where you can see it's the e-ticket version of that. You can see the standards. You can see again that it has less information than the previous one, but again it holds lots of stuff that's useful to get out of a machine. So here is the attack vector. Owning the machine that we previously showed, we can do the following. We have a traveler going to a kiosk and scanning his ticket. We have a malware on that kiosk, the point of sale malware that we're going to discuss later more about it. It has RAM scraping capabilities, so whatever is in its RAM, it's ours. And what we're going to do is that we can exfiltrate that information and maybe clone the ticket if we want. So we can get through the tax-free area and get some alcohol for, cheaper. Okay, so two things are that of interest here. The first one that's up there is that we need a malware to do these things, and then we need an application to help us with a duplication or other stuff that we'll explain later. So, the malware. The malware must have the following capabilities, as most malware must have. Run on the background and perform the RAM scrapping that we've talked about before in order to get every e-ticket that was scanned before. And what else? Maybe exploit the web camera module that Nick talked about and get some picture of the guy scanning so we know who he is while he scans. And of course, to do so, you have to hook the barcode scanner so you can synchronize the picture taking, because else you will take pictures, random pictures. And maybe have a capability of getting commands through a QR code that you give him, so we could just scan a specific QR code and get money out of the machine, because we can do that. And of course, it would be great if it had a connect back process, but even if it didn't have that, we could give commands through the QR code again, so it's fine. So let's go through the... Okay, this Yes. So, the image capturing. The image capturing is harder than you think because you have to hook and synchronize the barcode scanner with the camera, and this is not that easy because the RAM scrapping thing works asynchronous. It runs like every 2 hours and gets all the information that is scanned. So you have to just store the images there, have them in place, and then combine them to see who was actually scanning his ticket at the specific time. So it had some drawbacks. Most of them had to do with timing and also correlating the images with the traveler data. And of course, when you create files inside the system, you might get noticed easier than without doing so. So it's mostly deactivated, but you can do that. You can actually do that attack. A little bit about the RAM scrapping, which is, I believe, the most interesting part, and it's what characterizes this attack as a point of sales attack. It's the RAM scrapping thing that happens in every point of sales attack. So you have three things that you do in a point of sales attack. You extract the RAM of the process that you want, probably the barcode scanner. Also, it's interesting to attack the Explorer process, and you should do it periodically, around every 2 hours maybe, because it's a time-consuming process, so you can do it every 5 seconds, let's say. And the second thing you do is you search. You search for the string that's interesting. In our case, the string is the QR code with your traveler's information, so which is decoded inside the RAM. So you are looking for fixed sizes, you're looking for specific values which are fixed in our case, and for using regular expressions, you get the information you need. Sometimes you have false positives, you get them too, because you can, clear things later, and you store them. And the third thing is that you do the exfiltration. Okay, the exfiltration is a bit harder because you have to choose between, if you have connectivity, it's okay, you send it back to you. Try not to get code. And if not, you just store them locally, and then you go there physically and send a command through your QR code, and it brings back all the information you need. You get them by, maybe scan them again or write them down or whatever, and you go home. But here's how it looks when you do it through volatility, dumping a process, getting the information. It's in there. This is from a real machine, done on of course, in a virtual environment, but on a real process scanning a ticket. And you discard what's not useful, and you get what you want out of the machine. So, and the third thing that we wanted our malware to do is get commands from as the code. So it will scan a specific QR code and as the code and do stuff, like example, turn on and off the image capturing thing, or exfiltrate a specific thing, or maybe send some network commands if we wanted to. So that was another thing that we want our malware to have. So we had on the one end the malware that was standing by on the machine that we hacked, and we had another tool that's a multi-purpose tool. You can use that tool in order to do 2 or 3 stuff. I'll explain. It works, again, it's an Android mobile. You'll get that with material of the conference. And it had 3 modes. It supported PDF 4.17 and as the code, and it had 3 modes. The one was in order to duplicate easier stolen tickets. The second one, the pen test mode, which is the most interesting mode, is fuzzing the barcode. Nick talked about that, and I'll explain later. And you could use all your favorite commands that you can store in a text file and load through our fuzzer. I'll explain later, and attack the barcode. And of course, we had the malware command mode, where you would actually send commands to the barcode to the malware that was installed on the kiosk. So the duplicator mode looks like this. You scan your ticket, and we use this for impersonation reasons. So you want to create a ticket that, like this. So you input their information, and you just create another ticket. Then you go to the check. You show your ticket. It's valid. It's from another guy. Try not to use a women's ticket if you're a guy. and probably you'll go through that first check and get that free boost. And then some more information about the fuzzing. Okay, here for the fuzzing we have 4 types of fuzzing: string, integer, random, and predefined. You have all the SQL and XSS fun there. You want that actually worked in other systems, not that kiosk, but it worked and crashed other systems. So it's pretty useful. You should try that. You should download the application, do your own research if you want. And how the fuzzing works, you just, down there is the ticket that you had. You just place where you want the fuzz to be, and then you start. It generates barcodes every 5 seconds. You can set your own intervals because the QR code readers have different intervals depending on the machine that you are attacking. So you choose your intervals. This starts generating QR codes attacking the QR code reader. You can stop it at any time, copy the code and use it later, or stop it and then go one by one on your own pace in order to test the system better. So, and the last one is the commands that I talk about. So you can choose what commands you want to send. You can actually send dump ramp commands, and you can perform network scans. So you can actually set on and off the image capturing thing, or you can cash out money depending on the command you want to send. The way you do it is you select the command is generated on your mobile application, the malware is running on the machine you want, and in this occasion I'm sending, let's say, the last scanned person command, and the malware responds back with a pop-up window. This is the guy, this is his picture, this is his data. You get what I'm talking about. So, closing. What you should do and what you should not do. What you should do, especially for those manufacturing kiosks like this, you should use strong passwords to access the point of sale devices. You should keep your point of sale software up to date. This is the most important thing. You should not use buggy software on kiosks. This is not there, but you should use your firewalls to isolate the point of sales production networks from other networks on the internet. And of course, it's a good idea to have an antivirus there. Not that it will, identify all malware running, but probably some would. You should limit access to the internet if possible, and disable all remote access to the point of sale system. And one good idea is to check both the hardware and the software running on the kiosk, and not separately. You should check them as a whole. This is very important if you want to identify more and more attack vectors for the system and keep it secure. So this is all from me. I don't have... Do you want to talk more about?
Furthermore, just to add a point, you have in all the airports a lot of kiosks like that who provide free internet access, or they give you some functionality to have in the airport, okay, to play some games or to Skype talk with your girlfriend and do stuff like that. If you can imagine, if the attacker can own these machines which are on the same network, okay, how much time he will need to get deeper into the airport's network? Okay, because it's not the fact that you can just attack all the passengers who will pass by the kiosk or the machine who will surf the internet and put their credit cards. It's not only that. It's the fact that having an attacker being there for 30, 100 days the year with infinite time, that means there will be a case that he will go deeper into the airport's network. That means a real threat to the airport. Furthermore, we have another room next to us here where they are developing router exploits at the moment. Okay? So I don't know if the routers and the firewalls are enough. So the best solution to these kind of problems. If you have in an airport kiosks that provide user services, the best solution is to physically have different internet lines, different equipment for this type of information from the airport. So,
furthermore, one else thing that I would like to point out is that also, although this attack against passengers seems random, it can get more specific and more personal if you want, using a little bit of social engineering. So, from what you see here, it's like, okay, Alex, you're attacking random strangers that are traveling. You're not attacking the specific person that you want to get information from. But it's not true if you get some social engineering in that, since you own the machine, and most of the people traveling would probably think that it's a safe machine to use, and we can run anything on that. I could run a campaign like a phishing campaign on that machine, and then go around to a line of people waiting to get their tickets. One of them is the guy that I want to attack. And I'll be like, oh, sir, if you're traveling, here is a QR code. You can use that on that machine and maybe get free Wi-Fi. So he'll go there. He has his, all you have to do is scan this code and your ticket, and you'll get free Wi-Fi. And he'll just go there and be, okay, yes, let's get some bonus. If I'm even worse, I would be like, okay, and you'll get some free money from that machine. Scan that code.
yes, with a bug.
Money will get down from the machine slot. So he'll be like, oh, he was a cool guy, but I got his information. So, okay, yes, it seems random, but it's not that random if you own a machine and people trust that machine. You can get them to use that machine. You can get that machine work for you in your favor, and you'll get what you want. It's not that random. Okay, it seems random, but it's not. I think that's all from us. Do you have any questions?
Yes.